Today we're going to talk about ratios and proportions. Now I know this is titled Study Guide Intervention, but it is our notes for this section, section 2.6. So let's make sure we know what the words are that we're talking about. Ratios. So a ratio, I know it may not seem like it, but ratio has lots of the letters inside the word fraction. A ratio is often written as a fraction. Now there are other ways, so I won't get ahead of myself. Let's read this. A ratio is a comparison of two numbers by division. The ratio of x to y can be expressed three ways. You can write x, the word 2, y, x colon y, or x over y. And with few exceptions that we'll talk about, ratios should be expressed in their simplest form, meaning if you can reduce it, reduce it. An equation stating that two ratios are equal is called a proportion. To determine whether two ratios form a proportion, express both ratios in simplest form or check for equal cross products. Okay, so if we look at this by itself, 24/36, that is a ratio. If we look at this by itself, 12/18, that is a ratio. But once we set two ratios equal to each other, that equation is called a proportion. So just one by itself, it's a ratio. Two set equal to each other are proportions, or a proportion. So there's two ways we can solve it, like they talked about. One is just to reduce the fractions and see if it comes out equal. So 24/36, both 24 and 36 can be divided by 12. 24 divided by 12 is 2. 36 divided by 12 is 3. So 2/3 is what 24/36 reduces down to. 12 and 18 can both be divided by 6. 12 divided by 6 is 2. 18 divided by 6 is 2. So since they both reduced to the same fraction, that means they are in fact equal to each other. And that will be the method I think is best most of the time. But this other method is equally good. You can cross multiply 10 times 45, that gives you 450. 18 times 25, that also gives you 450. Since both sides are equal, that means these are equal. So either method can work. I'm going to use mostly the first method though. Okay, let's try. Number 1. Determine whether each pair of ratios are equivalent ratios, right? Yes or no? Okay, 1/2 is as simplified as it can be. So that's already done. 16/32. We got to think, what's the biggest number I can divide both of those by? Well, that'd be the number 16. If I divide 16 by 16, I get 1. If I divide 32 by 16, I get 2. So you notice, 1/2, 1/2, they match. So yes, they are equivalent ratios. Okay, 5/8, that is as reduced as it can be. 10 and 15 can be divided by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So see, those are not equal to each other. 5/8 and 2/3 are not the same, so no, those are not equivalent ratios. Hit number 3, 10/20, 45/49, 25/49. So both of these need to be reduced. 10 and 20 can both be divided by 10. 10/10 is 1. 20/10 is 2. 25 and 49. See, 5 goes into 25 and not 49. Oh, sorry. 49, 7 can go into that, but it can't go into 25. So this one actually is already as simplified as it can be. There's no number other than 1 that goes evenly into both of these. So it is fully reduced already. So these two are not equal, so we have to say no to that one. Okay, now this may seem complicated because of the decimal, but it's not as bad as it may seem. We've done this before. We don't want a decimal instead of fraction, so let's move the decimal over one spot. Change that to a +1. move it over there one spot, which makes it a 20. So now we've essentially multiplied the top and the bottom by 10, because 10 times 0.1 is 1, 10 times 2 is 20. So that's reduced. So let's see if we can reduce the other one. 5 and 100 are both divisible by 5. So 5 divided by 5 is 1. 100 divided by 5 is 20. So we have a match. So we would say yes, they are equivalent ratios. Number 5, 15 and 20 are both divisible by 5. So 15 divided by 5 is 3. 20 divided by 5 is 4. 9 and 12 are both divisible by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So those are equal, so our answer is yes. Okay, 6. 14 and 12 are both divisible by 2. Divide 14 by 2, you get 7. Divide 12 by 2, you get 6. 20 and 30 are both divisible by 10. 20 divided by 10 is 2. 30 divided by 10 is 3. So they do not match. So we would have to say no, these are not equivalent ratios. Now, one small trick, so sorry, I don't know why the yawns have got me, is that I knew as soon as I looked at this, these are not equivalent, because this number was bigger than 1. 14 on top is bigger than 12 on the bottom. So that number is bigger than 1, where the smaller number's on top, 20 over 30, so that one's smaller than 1. So just by that fact alone, I knew this one was a no. Okay, number 7, 5 divided by 5 is 1 over 1, or you could just say 1. 30 and 20 can both be divided by 10. 30 divided by 10 is 3. 20 divided by 10 is 2. So those are not equal. So I have to say no, they are not equivalent ratios. Number 8. 18 and 24 are both divisible by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. 50 and 75 are both divisible by 25. 50 divided by 25 is 2. 75 divided by 25 is 3. So those do not equal up either. So we would say no on those two. Okay, last one on this side of the page. 175 are both divisible by 25. 100 divided by 25 is 4. 75 divided by 25 is 3. 44 and 33 are both divisible by 11. So 44 divided by 11 is 4. And 33 divided by 11 is 3. So those are equal, which means yes, they are equivalent ratios. So this side of the page dealt entirely with ratios, reducing them and seeing if they are equal. The back side will talk to us about how to solve a proportion. So now they're going to throw in variables for us. Now this is where the cross multiplying is very, very helpful. So cross multiplying is best to use, and here's the rule for it, as long as the denominators don't equal 0. Because I don't know how much you've talked about it in your math life, but you cannot divide by 0. It is impossible. No one can do it. It's not because you're in middle school, it's because no one can do it. So B and D cannot be 0, but that's usually not an issue anyway. But then you can cross multiply. A times D, the diagonals, equal B times C, the other diagonal. So in this example, they're like, all right, we need to solve for x. So to solve for x, they cross multiplied. They did x times 13, which is 13x, 5 times 10, which is 50. So they had 13x equals 50. They divided both sides by 13. Now, if you want to leave the answer just like this, x equals 50 over 13, I would accept it. If you'd rather change it to a mixed number like they did, that's also fine. I'd accept this answer too. Because 3 goes into 50 3 times, that adds up to 39, leaving 11 left over. Okay, so number 10. 2 times x equals negative 3 times 8, which is negative 24. Now we divide both sides by 2. We get x equals negative 12. Okay, 11. 5 times t equals 1 times 3. We'll divide both sides by 5. And we get t equals 3/5. Okay, now number 12 adds just a little bit extra to it, because we're not just multiplying by x, we're multiplying by x plus 1. So when this happens, you need to put parentheses around x plus 1. 3 times 4 is 12. Now, if you want to distribute it, that is 100% okay to do. You can definitely get the right answer that way. For this one, I'm going to decide just to divide both sides by 4. That leaves me x plus 1 equals 3. We subtract 1, and we get x equals 2. Now, I will distribute on the next one, just so you can see it works either way. We have b minus 2 times 4. So I'll put the 4 out front in parentheses around b minus 2 equals 4 times 12, which is 48. So we could divide both sides by 4, just like I did in the previous problem. But we could also distribute 4 times b minus 4 times 2. Then we'd add 8 to both sides. Divide both sides by 4. You get b equals 14. Last one. 4 times negative y, so I'll just call it negative 4y, equals 8 times parentheses 3 plus y. So I'll do the distributive property on this one, but you could do it either way. Negative 4 times y equals 24 plus 8y. So I'll subtract 8y from both sides. Negative 4y minus 8y is negative 12y. Then we divide both sides by negative 12. We get y equals negative 2.